Hi, I'm Tosh Dalday. This is SDG Labs. Delta X equals V naught T plus 1 half AT squared, and that's a fact. Jack and Jill went up a hill to fetch a clumsy Jill. Anyway, hey, we're going to be solving this one. Jack and Jill carry a pail of water, and they obviously are mathematicians. Here's what I got. I got a pail that has a mass of 1.30 kilograms. I suppose that's maybe full of water. Jack pulls with a force of 7 newtons. Jill apparently is much stronger than him and pulls with a force of 11 newtons. She's pulling at an angle of 28 degrees. He's pulling at an angle of, I don't know. So I'm going to just let it be theta. The question is, they want this thing to accelerate directly upwards. What angle does Jack pull with in order for that to happen? Alright, here's what you do. What you're going to need to do is we're going to basically apply this same equation. Sum of the forces equal to mass times acceleration. And what we're going to do is we need to break it up into its horizontal and vertical components. So really, the first thing I do whenever I see a vector that has an angle, I take, okay, well, this is 7 newtons at an angle theta. I'm going to call this one, let's call this one A and B. And then B equals 11 newtons. So this is the 7 right here. This will be my AX, and this will be my AY. AX is equal to A sine theta. Well, this is A. And AY is equal to A cosine theta. Similarly for B, let's just do that here. B, this is BX, which is equal to B sine theta, or sine 28 for that matter, because Jill's angle was 28, and B cosine 28, because in here is 28 degrees. Alright, I broke it up into its components. Now, if I want to add up the forces, what I need to do is I add them separately. I'm going to add up all the forces in the x direction. I'm going to add up all the forces in the y direction. Let's add up all the forces in the x direction. Now, is it accelerating? Yes, it is accelerating, but is it accelerating in the x direction, since we were talking specifically about the x direction in this particular case? And the answer is no, because I told you that they wanted to make sure that this thing is not accelerating right or left, it is only accelerating up and down. So that A is 0, or ideally it should be 0. If I add up all the forces that I see, I'm going to refer to this one, these ones over here. I see an AX and a BX. Now the BX is positive, the AX is negative. I don't see any other forces in the x direction because I replaced this diagonal one with this horizontal and vertical one. I replaced this diagonal one with this horizontal and vertical one. So there aren't any other forces to deal with, in the x direction that is. So I get that BX is equal to AX, and BX is B sine 28, AX is A sine theta. So if I want to figure out what theta is, I know what A is 7, and B is 11, see, 7, 11. Man, Jack, step it up, dude. Why is your sister like pulling almost twice as much as you? Alright, whatever. Alright, I'm going to divide both sides by A, again, I'm getting that. I'm going to divide both sides by sine. I can't do that, you don't know how to do that, I don't know how to do that either. But what I can do is I can take the sine inverse of both sides. So sine to the negative 1 of B over A sine of 28 is equal to theta. Because the sine inverse of sine is just, you take off the sine. That's equal to theta. If you want to calculate that out, you end up getting 48 degrees. Plug it into your calculator. Make sure your calculator mode is in degrees, not radians, and you get 48 degrees. All right. Now what we want to do is we want to take care of the x or the y value. We want to figure out what is the acceleration. So now that we got the x values, let's add up the forces in the y direction. All right. Sum of the forces in the y direction is equal to ma. That is the mass times acceleration in the y direction. Is that 0? No. Because I told you in the x direction it was 0, in the vertical direction it wasn't. It doesn't need to be. So that's mass times acceleration in the y direction. We got to figure out what it is. What forces do you see? Well, I see AY and I see BY. Well, AY is pointing up, BY is also pointing up, so I'm going to add them and I'll be happy. It's equal to mass times acceleration in the y direction. I divide both sides by m and I end up getting my acceleration. So I'm pretty much home free. AY is equal to A cosine of theta, which we calculated out to be 48. And BY is B cosine of 28. All divided by m. M being 1.30 kilograms. So A is 7, this is 48 degrees, this is 11, this is 28 degrees, this is 1.30 kilograms. So you plug those into your calculator. I'm going to do it in my head. I'm getting about 1.2 meters per second squared. And that's my acceleration based on all of the physics of it. Jack and Jill, engineers. Oh yeah. Shoots, bro. Up out.